Hello, everyone. Welcome back to Advent of Code. Today's the day 15, excuse me, of 2023. For a change, I happen to be doing it about when the problem is released. We're still not hitting any global leaderboards. In fact, I wonder, are they full already? It's been 12 minutes. Day 15. There's someone in 100th place for part 1 and part 2. Yeah. Okay. Just interested, but not very. Let's have a look. What's going on? Lens library. Ooh, Haskell has a lens library. Ah. The newly focused parabolic reflector dish is sending all of the collected light to a point on the side of yet another mountain, the largest mountain on Lava Island. As you approach the mountain, you find that the light is being collected by the wall of a large facility embedded in the mountainside. You find a door under a large sign that says Lava Production Facility, and next to a smaller sign that says Danger, personal protective equipment required beyond this point. As you step inside, you are immediately greeted by a somewhat panicked reindeer wearing goggles and a loose-fitting hard hat. The reindeer leads you to a shelf of goggles and hard hats. You quickly find some fit, and then further into the facility. At one point, you pass a button with a faint snout mark. Snout mark and the label push for help. No wonder you were loaded into that trebuchet so quickly. So is this who summoned us? Okay, maybe. You pass through a final set of doors, surrounded with even more warning signs, and into what must be the room that collects all of the light from outside. As you admire the large assortment of lenses available to further focus the light, the reindeer brings you a book entitled Initialization Manual. Hello, the book cheerfully begins, apparently unaware of the concerned reindeer reading over your shoulder. This procedure will let you bring the lava production facility online, all without burning or melting anything unintended. Before you begin, please be prepared to use the holiday ASCII string helper algorithm, Appendix 1A. It abbreviates to hash, I guess is the joke. You turn to Appendix 1A. The reindeer leans closer with interest. The hash algorithm is a way to turn any string of characters into a single number in the range 0 to 255. To run the hash algorithm on a string, start with a current value of 0, then for each character in the string starting from the beginning, determine the ASCII code. Okay, that's easy. Increase your current value by the ASCII code. Multiply the number by itself. Multiply the current value by 17. And set the current value to the remainder of... Okay, so do it mod 256. The initialization sequence, your puzzle input, is a comma-separated list of steps to start the lava production facility. Ignore newline characters when parsing the initialization sequence. Okay. To verify that your hash algorithm is working, the book offers the sum of the result of running the hash algorithm on each step in the initialization process. So this part looks very easy, but it does bode somewhat fearful for part 2, because this looks like some kind of program, and we may need to write a computer to simulate it or something. Alright, well, let's have a look at the input, I suppose. Nope, that's not what I meant. I thought I got my input file already. Where did I put it? Oh, in day 14, apparently. Whoops. Well, actually, get the day 14 input and put that back, I guess. Are all my other windows in the right place? Why is stack GHCI still hanging? I started this like 10 minutes ago. What? Oh, okay. It was already there. I see. Right. I somehow accidentally sent the process to the background, and then it didn't print anything when I brought it back to the foreground. I just didn't read the history of the shell very well. Okay. So, here we go. Well, there are no new lines to ignore, so that'll be nice and easy. Huh? Huh, okay. Tells me to ignore new lines. Oh, but there is one at the end of the file, I guess, is the... So we're supposed to ignore that, sure. Okay, so wait a minute. How then do we parse... Because we're supposed to get the hash of each instruction, right? Sort of? No. We're supposed to hash each character and not use... Yeah, okay, fair enough. We'll just ignore the new line. So technically, our parse function could just be init, where we drop the... We assume there's a trailing new line and then we drop it. But I think I would rather have something that works for arbitrary number of inputs, of lines. And that's not very hard either. So our input is actually just a string. And if we just call lines on the string, it'll give us back a list of lines without the new lines in them, and then we'll concat those together. And that'll be the input with all the new lines removed, basically. Actually, you know what? It's even simpler to say filter not equal new line, right? That's also more in line, like a more explicit representation of what the problem statement is, which says ignore new lines. Why turn it into lines and then concat it if your goal is just to remove new lines? Sure, fair enough. So let's write a hash function. You know what, let's write a hash string function. Because the hash doesn't really apply to a single character. It needs some state. So you could write it as a stateful function, but I don't know, it doesn't make much sense. Actually, hang on. Is this even easier than I thought? To hash... After... Okay. Okay, so does it say something about commas in here? Because it seems like the commas are important somehow. Yes. The initialization sequence is a comma-separated list of steps. Okay. Got it. And we're supposed to hash each of those independently, right? Yeah. Okay, so actually it's a list of string after all. What's a good way to divide a list at... It's like there's something in data list split, right? Split on... What is Yeah, split. Oh, it takes a splitter, yeah. So, like, obviously using a parser, we could write sep by comma, for example, right? Parse many foods sep by comma. But here, like, it's so simple to just split on commas. And, like, this is kind of all I actually want, right? Split on X. So let's just go check out my Cabal file and say I need split this time. It's split on comma. Import data list split on. Okay, cool. So now we have our parser for, hang on. We have to also, we have to still not include the new lines, right? What does it actually say about new lines? It says ignore new line characters when parsing the initialization sequence, which I guess is what we're doing before we do anything else. So yes, we'll throw away all the new lines in the whole string. So we're gonna need ord for getting the ASCII value of a character. Hash string takes a string and returns an int. Oh, you know what? We're gonna also need import data list fold L strict. Fold L is in the standard library, but it's like never the function you want to use because it's too lazy for no value. I believe it is sort of known that there's exactly one use case where you would want fold L, and it's not a practical use case anybody has. So you should just always use fold L strict if you're going to fold left, or fold R if you're going to fold lazy. Hash string is... Oh, wait, but the point is... No. I thought I might want to scan L at some point, but we only need the... We need the current value multiple times, but only once per string that we're hashing. It's just fold L strict of hash starting at 0, where hash of the accumulator's on the left, so current and C is we get ord C current plus ord C times 17 and all of this mod 256. And I think that's it. Part 1 is some map hash string. So let's just try running that, shall we? It's a number. We were supposed to add them up, right? Yeah. It even mentions the initialization is one long line. Be careful copy pasting it. Sure. Yeah, that's the right answer. Pretty easy. think we're just adding everything, right? Yeah, okay, we need to add split. I'm sure that like you can use span and break, but I don't think there's anything in data list that's quite, is there? That does the splitting that I would want. Let's have a quick look before I move on, actually. Yeah, see, none of this. Ooh, what about by? No by, delete by, no group by? No. I mean, I guess you could group by equal comma, sort of. But not really. Okay. Day 15, part 1. All right, easy enough. Head on to part 2. Gonna be much harder, I assume. You convince the reindeer to bring you the page. The page confirms your hash algorithm is working. Bring me the page? What page? There was something that was going to confirm my thing, but what? It was a page? Appendix 1A has the algorithm. Just search for the word page. Ah, the reindeer has stolen the page containing the verification number. I see. The book goes on to describe a series of 256 boxes numbered 0 through 255. The boxes are arranged in a line, starting from the point where light enters the facility. The boxes have holes that allow light to pass from one box to the next all the way down the line. Inside each box, there are several lens slots that will keep a lens correctly positioned to focus light passing through the box. The side of each box has a panel that opens to allow you to insert or remove lenses as necessary. Along the wall, running parallel to the boxes, is a large library containing lenses organized by focal length ranging from 1 to 9. The reindeer also brings you a small handheld label printer. The book goes on to explain how to perform each step in the initialization sequence, a process it calls the Holiday ASCII String Helper Manual Arrangement Procedure, or hash map. Each step begins with a sequence of letters that indicates the label of the lens on which the step operates. Each step begins with a sequence of letters that indicate the label of the lens on which the step operates. Running the hash algorithm on the label indicates the correct box for that step, okay? The label will be immediately followed by a character that indicates the operation to perform, either equals or dash. Sorry, where's the... What is a label? I guess a label is the part of the instruction before the equals or dash. Okay. If the operation is a dash, remove the lens with the label if it's there. Then move any remaining lenses as far forward in the box as they can go without changing their order, filling any space made by removing the indicated lens. If no lens in that box has the given label, nothing happens. If the operation character is an equal sign, it'll be followed by a number indicating the focal length of the lens that needs to go into the relevant box. Be sure to use the label maker to mark the lens with the label given in the beginning of the step so you can find it later. There are two possible situations. If there's already a lens in the box with the same label, replace the old lens with a new one, keeping everything in position. If there isn't a lens with the same label, add it to the box behind any lenses already in the box. Okay. all the boxes are always present. Only the boxes that contain any lenses are shown here. Within each box, lenses are listed from front to back. Sure. Each lens is shown as its label and focal length in square brackets. Add up the focusing power of all the lenses. Focusing power of a single lens is 1 plus the box number of the lens in question multiplied by the slot number of the lens in the box multiplied by the focal length of the lens. Sure. So each box we can compute the focal length of independently. And then we can add the results together for each box. Okay, I mean, a nuisance, but... Now, so what? How do I determine which box it is? Is it to hash the whole string or just the label? Yeah, you hash the label. Okay. Fine. So now we actually need to further parse the input for part 2, and we need to define some types for that. I mean, do I actually even need the RE type? Maybe I can just let it be implied. One thing we certainly need is equal tilde. We probably want sim and psim, I guess. We need some. What else do we need to parse the input? Not much, I think. We need a way to choose between two alternatives, I guess. So let's just import or. And I guess we're going to want, well, hang on. How many spaces for lenses are there in each box? Lenses labeled by focal length. Okay, hang on. I don't remember how we figure out what the focal length of a lens is. Oh, when we put a lens into a box, it comes telling us equal sign a focal length of the lens that needs to go in there. Okay. But a focal length is 1 to 9, right? Yeah. So I think we don't really need a whole full-fledged digit parser for this. We'll just use digit to int after parsing a single thing. So yeah, I know this is all redundant. Give me a break. Data. What are these called? Instructions? Each step begins with a sequence of letters, the label. They're called steps, I guess. Okay. A step is a step with a label, which is a string, and then it contains an op, I guess. Oops. Well, I don't know. I'll just string op, I guess. I don't think I'll need eq or org for any reason here, so we'll just derive show and that'll be that. Data op is remove or insert focal length, I guess, where type focal length is just int. So now we can construct steps like it's the step, you know, they have an example, PC equals 4. So that would be an insert of 4 on step. Not on step, on PC. I keep forgetting how we figure out what the... We hash just the label to figure out where it goes, right? Yeah. So we can never have two different lenses with the same label in different boxes, because the label tells us uniquely which box it goes into. So I guess what we can do is use... Gosh, do I really want a mutable array? Is that crazy? Kind of makes sense, right? An ST array again? And then we're just going to iterate over each of the steps. The other thing is, how do I want to represent the contents of a box? I think I want it to be a sequence, right? Because those are efficient to edit in the middle. A sequence is, sequences is another one of the tools in the containers library that has maps and sets. There are lists that have efficient split and concat operations, and therefore efficient edits in the middle. Yeah, I mean, it makes sense. Like, I guess I want an ST array of stuff again. So let's go borrow some inputs from yesterday so I don't have to remember what they were. 14. No. I want this. And I want that, at least. Okay. I probably don't need get bounds because I know what the bounds will be. I don't really need IX. I'm going to index things by int. Read array and write array, that makes sense. New list array, I don't think I need. I want like new array, initializing them each to like empty box, right? Yeah, so that's fine. That's just new array. Read, write. I don't think I need to get a so because I probably want like, actually I kind of do. Because I want to know for each box like what key it has and what its value is at the end. And I need to add, oops, not my input, but my Cabal file, please. I need to add array here. Sure, this should have show as well. And let's I want to write the parser now. So let's say step is a function. I'm not going to use the parser type here. I just want a function from string to step that'll be partial. Step is from maybe no parse, as I so often do. Oh, error of no parse. Composed with match the step matcher, where step is step mapped over some I guess I just want any sim, huh? Because I don't have to specify, oh, don't consume the equal sign, because like the equal sign needing to be parsed will take care of that anyway. Like if some any sim tries to consume the operation symbol, then the regex won't match, and it'll have to give those characters back. This is one advantage that regex applicative has over parsec and the like. It's not a large one, but you get backtracking for free with regex applicative, because it tries all possible ways to match in parallel efficiently. With parsec, when you consume a character, you're committing to, the parser that you're looking at consumed that character. If that parser then fails further through, you can't back up and try an alternative. You can tell parsec, hey, I want you to backtrack in this section by wrapping it with try, and that's fine. But it costs you something, and you have to remember to do it, whereas with regex applicative, it's just free, which is nice. So any sim and then an op. An op is remove over sim hash or minus, or it's insert digit to int mapped over an equal sign, which we ignore, and then parse a sim. I guess it turns out I don't need psim. Didn't have from maybe, of course. Import data maybe from maybe. Sure. What is this type error? sim is applied to too many arguments. Oh, yeah. Any sim. We intend for it to be a digit, but that's fine. It should be. So we can test this by saying parse, you know, they had like CP equals 4, I think, as an example. Yeah, turn CP in, should be insert 4, you know, minus, great, right? So that works fine. So, given that our parser works, what are we doing next? Defining, I guess, like, we probably should define a type for, like, a type alias for the array we're going to be using. Which will be an st array of seek of int. No, seek of... Ah, well, of course. We need a type for our lens, our boxes, right? Well, no. Because as the box is just going to be a list of lenses, and that's it. But we will need, like, data lens is a lens of string, which is its label, and focal length, right? I think we probably might as well also derive show here, but nothing else. And I need data sequence qualified as S, please. So that I can say type box is a seek of lenses. Right? Yes, that is a legal type. Very good. And finally, we can say our type, you know, grid of S, just like we did before. When using st, you have to have a type parameter that, like, you never touch, but st can touch. This is the way the type system forces you to promise that you never pass through the st barrier. Grid of S is an st array parameterized by S, indexed by int, containing boxes. And then I think we just want a function that, given a grid of S and an instruction, no, a step, modifies the grid by following the instructions the step represents, right? That makes sense to me. Let's say run step. Oh, typed the wrong character. I was like, why wasn't... I hit control semicolon instead of shift semicolon and nothing happened. And I was like, what? Okay, so run step. I just said what type this thing has. It takes a grid of S and a step and produces STS unit. We will produce no result. We'll just do it. This way we can just like map M, which is traverse, over the list of steps, applying them all. And we can partially apply the grid. And then at the end we can read what the array is. Okay. Run step G and step label op. Ooh, having deja vu. I feel like I wrote this already. I didn't. Did I write something like it this year? I don't think so. Just you know, your brain tricking you. Okay. So a step contains an op, which we'll look at in a moment. What are the operations we have in array? Is there like modify or something? There is. So actually I don't need read array and write array. I just need modify array. We're going to modify a specific index. Modify array at hash string of label with run up. Does that make sense? I could pass run up, label and op, but I'll just make run up a local function that refers to them both. Run op of box is case op of, what do they call them? Remove and insert. If you're supposed to remove that label, then I assume sequence has like a filter function. Let's look at the docs for data sequence here. Well, I'll just search for filter. It'll be in there somewhere, right? Yes. So this is not efficient or anything, but you know, you can't really be that efficient. You have to scan the whole box anyway. Like, I guess, okay, you could have a box be like something horrible, I don't know, where it's available by index and also by label, but I don't know, it just seems hard. So we'll take filter. Is s.filter keep of box, where keep lens, we call this a lens, right? Yes. Label prime if label equals, I don't, right, I'm only filtering here, equals label not equal label prime. Right, so we pattern match on the lens that's there, and for any labels we can find, we remove any lenses that have the same label as the one we've been told to remove. Seems simple enough. Insert is the more complicated one. I don't think it's like horrible. We'll just say focus. But the trick is that we have to either replace the existing one or insert a new one at the end. So I bet if we read through this, there will be some cool function like alter F that lets me, like, let's look under transformations. Map with index. Fold map with index? Or actually just, maybe, is fold map enough? it's not great. Oops. Because, like, we could have... Actually, is seek itself a monoid? You would think so, right? Should be, right? Yeah, it's like a friggin' monad even. Okay, it's a monoid. Fine. So, what is it that I want to do? I want to, like, map over the list, the sequence, and I guess maybe just a traverse is simple enough. Because I need to map over the elements, but also keep track of whether I have made a replacement, right? And so that's like writer is, okay, do some other operation, but emit some information about how the operation went. Right? I don't think there's any particularly great thing other than that. I guess, remember mapaqml is kind of a way, usually, at least for lists, to do something like what writer would do for you, or indeed even state, I think. Do we have mapaqml on this? No. Interesting. Is that defined on foldable? Ah, it's defined on anything traversable. Which surely a sequence is. It's like everything, right? Why shouldn't it be traversable? It is. Okay. So we can use mapaqml to map over the elements, but also track whether we've hit it, right? And it doesn't really matter whether we use mapqml or mapqml, because all that changes is the order in which you do stuff. You combine the state things, and we're just going to be combining them from like false to true. Okay. So in this case, I guess we want to case. No. I don't know. Mapaqml of replace over the box of mapqml returns the state on the left. Okay, so if we found it, then we just return box prime. If we didn't find it, then we need to insert on the right a new lens with the appropriate. How do you do this in dataseek? Okay, it's Add an element at the right end is pipe right angle bracket. Okay. Takes its seek argument on the left. Okay, so it's box prime, pipe right angle, a new lens with label and focus, please. Where replace. Okay, in what order? How do you map QML take its arguments? The state, scene, lens, equals. And I just need to return the element there. I don't need to like wrap it in a box or something weird like that. Okay. Oh, I guess I need to match here. Lens label prime. If label equals label prime, then it's true. Oh, you know what? This, we know this is going to exist, right? I can say where new is this. Okay, so if we define the new lens, and we're either going to put it in as part of this replace, or here if we fail to find it when replacing. If we don't find it here, we just leave things alone. We say, okay, you know, scene stays the same, and the old label stays the same as well. Parse error and put equals. Line 39? Oh, where? Okay, sure. Yeah, let's indent this a little bit further left, shall we? Okay, how about now? Data array emarray does not export modify array? I thought it did. What's the one that I was supposed to get here? Looks like it to me. What did I spell it wrong? Look, it says modify array. I noticed this one has since fixed me and the others don't. Maybe is it new somehow? What version do I have? This is array 5.6. Or 0560. But I mean, I have 0540. I don't know whether this is a new thing. I don't know how to find out like what the history of a package on Hackage is. Modify array prime, by the way, is surely what I want. Like, I want to be strict. Not that it's a huge issue, but... Huh, this is annoying. Is it maybe in... Well, it kind of has to be in emarray, right? It can't be anywhere else. Because if it were like in data array or iArray, then mutate wouldn't make sense, right? Data array st, do you have it maybe? You wouldn't think so. Nope. Data array base, what is this? Don't use this, it says. Okay, how about data array? Incremental array updates. Okay, but this takes... It modifies an array and returns a new one, right? That's for immutable arrays. That's not what I want. Okay, well, I guess we'll just implement modify array ourselves. And I guess I'll implement modify array strict because it seems correct. I'd like to do a little exercise where I predict what modify array's implementation will look like. And then it just like for fun, I guess. So let's do that. We are apparently going to need read array and write array, after all. Let's just put it here, I guess. Modify array. I don't know, I'll put the tick to remind myself that it's strict, I guess. Is a function from... Oh, I don't even have... Hang on. I didn't pass an argument to this. G. Yeah. So this takes... it requires that there be an M array of type A, IE, and furthermore that the I is indexed. I cheated a little bit by peeking at the type signature for modify array in the docs there. It takes an A of IE, then it takes an I, and then takes an E to E and returns an... Oh, how do I get the monad? Where's the monad exactly? Oh, AEM. Okay, I don't understand. I've forgotten apparently what's... Okay, I peeked the type signature and still got it wrong. Oh, so an array, the type of an array takes two parameters. Its index and its element type. But it has to be part of a class that includes this M parameter, which is the monad it runs in. Yikes, okay. So that's the type given in the documentation for modify array. Modify array, we're going to reuse the index, so I think it makes A and I. I think it makes sense not to partially, like, to use currying here. AIF is like... Read array. I don't think I'm going to be writing it the way they do in the in the library. I'm realizing now. Read array takes the array and then the index. AI right, let's say, where right of old is new seek right array AI new where new is f old. This type check? Yeah, and I have to import mRay and IX, of course. And now I need map_L from data traversable. Oh, I needed to qualify that use of right pipe. I guess it's been a while since I saved the file, huh? Well, the good news is the type error is coming in. Well, actually, hang on. Are there multiple type errors? No, it's just in the map_QML call. So what are you upset about here? You expected a seek of lenses. No, you expected a bool, but you got a seek of lenses, huh? Oh, yeah, I didn't give an initial argument to map_QML. And it shouldn't go in that position, it goes here. Hey, no type errors anymore. So let's celebrate, I guess, by looking at the implementation of modify array strict. Oh, interesting. Oh yeah, bang patterns would be cute, I guess. I forget those are available. But they do bounds checking here, which I'm not doing, so fair enough. So I think we could just do this. Yeah. So bang patterns here. So I didn't even talk about what the seek was doing. Seek is one of the deeply magical functions in Haskell, i.e. it's one you could not write yourself. It takes, here I'll write what we had before. It takes a value on the left and a value on the right, and it just returns the value on the right. But it also tells Haskell, the runtime system, that is, hey, if anyone ever wants to look at this value, they need to look at this value first. You need to force it. Like, this should not be allowed to be a thunk, a delayed expression. So, I mean, it's not important. Since we're not like really building up big thunks, but I mean, in principle, if we had a large number of operations and we had a lazy modify array, since we never look inside any of the boxes in the array except to modify them, if I didn't have this new here and we ran like a zillion operations, we would start having a space leak where the value in each box would just start to become a larger and larger thunk. Every time you modify it, you would like put a note there saying, hey, if anyone cares what this value is, make sure you call this function before you give it to them. And then like you modify it again, and it's like you put a new wrapper around that what was there before, saying, oh, actually also call this other function before you give them the result. And the first time anyone looks, all those notes get consumed and then thrown away, and you save the actual value that was there. But since we don't actually look except in calls to modify array, and those don't need to look at the actual value, we would be building up a big old thunk. And so in principle, if we had a large enough input, this would run out of memory. So we use seek to say, don't let anyone even use the result of write array, which is an st value that definitely will be used, without first forcing the value of new. In that way, the thing in the array is always a value, not like a note attached to a value saying, please run this function before you give anyone the value. And using bang patterns here is just a shorthand way to say, like, any expression... I don't even really know what bang patterns does. I guess it says any expression using this should be qualified, like should have a seek new wrapped around it? I don't know. Interesting. So that's fine. That compiles. Very nice. We have our run step function, which, you know, compiles. Maybe it's right. And the whole thing is pure, except the call to modify array out here, right? Which says, oh, by the way, you're going to change what's at G based on the label. So, maybe we're ready to start writing part 2 now? Yeah, I mean, I think so. We're just going to part 2 of input, I guess, is well, we'll probably put that in a where well, maybe I never even need to let it be mentioned. I'll just call parse at some point, or map parse or whatever. Yeah, map parse. Run st of do, sure, why not? We need the array. G is new array. What order does that take its arguments in? The bounds, then the element. Okay. So the bounds are from 0 to 255. The element I want is an empty seek. Then I want to, for map parse input, Well, why just map over the input and call parse inside the function? Well, in that case, it makes more sense to say traverse, right? Traverse, what's my function here? Run step? Yeah. Run step of G composed with parse over the inputs, right? Over the input. I need the soaks, right? Yeah, so fine. Now that I've done this traverse, get a soaks of G. Actually, what do they call this function that compute the focusing power of lenses? Box power, I guess, over get a soaks of G, where box power of box num, that's our int, and label, or lenses is, what's the definition say? Multiply together, so let's just write product of box num plus 1 well, okay, I'm just multiplying two things, I guess. Box num plus 1 times map lens power of box, actually box num can be implied here, over lenses, right? Where lens power of lens, ignore the label, focus is, I can't just map, I have to know their index. Data sequence has something for this, I'm sure. What is it? Just search for the word index. Indexing, is it like a special fold or something? Folds, yeah, fold L with index, perfect. S fold L with index. No, I just want map with index, right? That'll give me a sequence, which is a little... It's a little annoying. I guess I just want fold map with index. Fine. Lens power over lenses is a product, because I have to make it a monoid for fold map, of annoyingly we're gonna have to call get product at some point. So what is it we're multiplying together here? The slot number of the lens. Oh, what is the argument order for fold map with index? I was just looking at this. Int first, so okay. Index plus 1, because the first box is supposed to be labeled 1, not 0. And then also the focal length of the lens. We need data monoid foldable here. Not foldable, product. Okay, give me traverse, please. It's in fucking foldable. Are you shitting me? Okay, good. A new type error on line 64. What did I do wrong? Oh, yeah. I mean, sure. I forgot to add those together. Sum of the box powers. Sum.map box power? Yeah, that seems right. Hey! Okay, it compiles. Certainly there's a lot of things that could go wrong, but wouldn't it be fun to just run it and see? Hey. I said go to this window. It's a number. It's bigger than the other one. It's positive, I think. Let's try it out. No, too high. All right. Fair enough. Now let's think about why it might be wrong. Any number of reasons, really. Why am I adding 1 to box num? I guess it's because the problem statement doesn't want box 0 to be unimportant. I mean, we wrote a lot of logic with no testing at all, and just counted on the type checker, and it's wrong, so we shouldn't be too surprised. So let's imagine, I guess, let's try our test input here. Our input is a list of string, is that right? Yeah. So if we say part 2, composed with prepare of this 37,935. What's it supposed to have been? 145. So this is way, way bigger than intended. Didn't you tell me my answer was too low? Okay. Okay, so let's... It would be nice if we could output like this, right? After each step. We can't really because we're in ST, not IO. Well, I mean, who says I have to stay there? I let the type of my grid be IO array and ignore the S parameter, and I guess it would also be helpful to I don't know. I'll just change this to IO real quick. IO unit. Oh, but part 2 isn't allowed to do IO. I could change that, of course. I don't know. Maybe I'll just use debug trace because all I want to do is print a couple things, right? Yeah. Put it here. Just import the whole module. Sure. So what I want is a function like show boxes or something, right? That I can call inside of I guess part 2. Maybe inside a run step, I don't know. It's kind of not an easy place to do it. The types I'm using don't offer me a lot of ways to interject. Right. Well, let's just say do here. And then we will we'll bind get soaks of G, trace show boxes soaks, and return nothing. Oh, these should be indented less. Oh no, run op doesn't. Okay, hang on. Right. Run op isn't in ST. Okay, it has to go like here. Let's remove this do that I just put there. Do modify the array and then like write all this, do this stuff. Unexpected case expression. Where? Okay, everything parsed wrong. That's the problem. Okay, what have I gotten wrong? This needs to be indented to the same level as new. Okay. And now I need show boxes to be implemented. Show boxes is a function from list of int and box to string. Show boxes is unlines.map show box, where show box actually we'll concat map or map maybe? Yeah, that's what I should do. Map maybe show box. Because I don't want to print out the boxes that have nothing there, right? And really, each box is... No, that's right. Each box we're going to print on one line, so that's fine. Data maybe... Map maybe. Show box of... We have a seek of lens here, right? That's what a box is? Yes. Uh-huh. And otherwise is just... box. I'll do it in exactly the same format they do in the puzzle. It'll be great. Oh, but B is, it's IB is actually what we have. An index and a box. Box I. And then add lenses, where lenses is, we're going to a lens. We need to like map over a lens. And get out a list, right? Oh, intersperse actually gives you a... I guess it's not really what I want though, is it? I guess if I call toList on the seek, then map a function over it that shows a single box, and then call words on that. Yeah, that makes sense. Is words map show lens toList lenses. And show lens of lens label focus is, how do they display it in the puzzle? We'll do it exactly the same. Square brace, label, space, show, focus, end. S dot, no, it doesn't export to list, huh? Okay. Just uses the foldable instance. Fair enough. So somehow I actually have a string? Did I forget to call show on something? Yes, show I. Okay, what types do you think everything has? Okay, I'll import, oops. I'll import toList from data foldable. Now there's even more errors. Lenses you thought should be a string, but actually it was a list of string. Well, I agree. I also want it to be a single string. Why is it a list of string? We're calling toList on the lenses, getting back to list of lens. Map show lens should give us a list of string. Oh, I want unwords, not words. Are we getting any closer now? Yes, only one error remains. You don't like toList. You thought it should be a function from string to list of lens, which is insane. And it actually was a function from string to string, which is also insane. Oh. No? Yes, this was supposed to be B. Lenses is this function. B is the box. There we go. So, I don't know. Maybe that works out. What happens if I just say stack run? Gonna get a bunch of gobbledygook to the terminal, hopefully. Yeah, it prints out a billion things. Who knows if this is right? And also, like, I kind of want to do this after blah blah thing, right? So is that easy to do in run step? Yeah. After I guess I can put the quotes in. It doesn't hurt anybody. After after show at S, which is not going to be exactly the same format as they have in the problem, but that's okay. And I also want to go get my test input and put it somewhere. would be a good way to do that? I guess just Emacs, you weirdo? Okay. Input test dot input dot text. I don't know what I usually call these stupid things. So my test input is this. Okay, so now I think I want to say part 2 composed with prepare mapped over read file. I already forgot what I called this insane thing. Test.input.text. Okay. Oh, well, so do I have the right RN1, CM2, both in box 0. Box 3 is OT7, AB5, PC6. So this is perfect. This is exactly what it should look like. The issue is just the way that I'm computing the focal length of everything. So let's review how that was supposed to work. Multiply together. I think the issue is that even empty boxes are getting credit somehow in my example. Right? Because I said, oh, I can compute the focal power for a box rather than like it wants you to iterate through all the lenses, and for each lens, like what box is it in, and then use that to but I can say, oh, I said, well, let's just look through all the boxes, and then for each one, add up, multiply up all the lenses in it. The problem is, if there are no lenses, the product of calling like focal score on all of them isn't 0, it's 1. And so I'm adding in all the boxes that for every box that's empty, I'm scoring it as like box number plus 1. So that should be like in the ballpark, given that most of the boxes are empty in our example here. Should be in the ballpark of 128 squared, right? No. 256 times 128. So like 2 to the 17th is how much I should be off by? No, the 15th. How much I appear to be off by, I think. Which is 30,000? And if you look, yeah, I mean, that's, my number is about 30,000. So, yeah, I'm off by about 2 to the 15th for that reason. Yes, okay, makes sense. So I just have to make a little fix to the thing that computes the focal length. Filter not null second, please. So just don't tell me about the empty boxes. And if I now reload this and run it, the number is way too fucking big still. 5,044. The answer is supposed to be 145. Okay, let's revisit how you compute the focusing power of a lens. Oh, I'm doing too much multiplication. I'm multiplying the box number by the focusing power. Sort of. Well, wait a minute. What is this wrong? I think, yeah. So the issue is I was multiplying this by box num plus 1. Well, wait, maybe this is right. Oh, but this is supposed to be the sum of all these things, right? We're not supposed to multiply together each lens. Rather, each lens is a product, but we multiply those together. So I think actually this was supposed to be get sum, and this was supposed to be sum. And then, okay, technically box num should be computed in here. But since we're going to multiply all of the terms by the same thing and then add them up, I can instead add them up and then multiply by that. So that should be okay. That's the right answer, 145. Okay, so if I now go back and remove all these dumb traces and just put that in. Don't need that either anymore. A much smaller number. Cool. Is it right? Who knows? Was I didn't mess up my part 1 answer. Nope, yeah, that's still right. Okay. Focusing power of the resulting lens configuration is the right answer. Okay. So some mistakes were made. I kind of like... I was about to say, I kind of like the ability to show boxes. And I guess I'll leave it in, even though I'm not using it. So that you could, in principle, like, visualize this a little bit better. I don't know. Ah! Yeah, git add p, I guess. I do need array, yes, and then I think I'm just committing all of this as is. Yeah, okay. Day 15, part 2. So, you know, part 2 took a while, but it wasn't as bad as some of the previous days where I really made things longer than they had to be. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.